Hi. So hope you all are doing well. So in this project, we have to integrate four different temperature sensors, and we need to log that the data from the sensors into the Excel sheet, and also we need to connect the SSR, the solid state relay, and we need to operate that relay using any of the data from a single sensor. So this is the description of this work, that we need to acquire the data using the analog front end. We have a LCT 2400 ADC, and each AFE is connected to the RTD temperature probe. It has a 4-digit precision in the temperature, and the range is from -5 to 100 centigrade, and we need a 4-digit precision. For example, if the data, then 6.64.235 centigrade with plus minus 0.0001 centigrade. Also we need to log that data into the Excel sheet. We need to implement a PID control. Obviously we do need a PID control in order to operate this SSR solid state relay using the output from the temperature sensors. So for that, the hardware available is NI PCI DIO32HS. This is a board, NI board, and two dedicated PFIs are required. So we need to create obviously we need to create the clock by ourselves, since this does not give the clock. So let's look at the LabVIEW file of this. So here let me show you the file. So here one, we have a digital input port, then next we have a clock, which will be a digital output which will go into the board, and this CS is also the digital output. So we are starting the task, then we are defining the read period, and in the read period we are turning on both the digital outputs, the clocks and the CS, and then we are deactivating the CS to 0 so that the data should start. After this, the data will be coming here, so we need to read that. Analog read should be used. So we are getting 32 bits data. So, and as per the template of the sensor, we'll be using the 24 bits, and the rest of the bits we will be ignoring. So we are running it for the 32 times. There is a for loop, and in each loop we will get a data. So here we are setting the clock as false, and then after a certain period that is defined, we are turning it on. So in this way we will get each bit of this. We also have defined the array constant here, and each iteration we are adding the data into this using the index array function. After this, so here we are extracting the different data from the array that we have gathered. So this is our 24-bit data, and after this we are converting this 24-bit data into the a value, an analog value, using this function. Then we are scaling it to 2 raised to power 24, so that value becomes scalable, and then using the reference voltage that we are using, which was 2.5 or something, 2.52, and we are multiplying it, so this becomes the temperature. This is the before temperature. So after that we collect 5 different samples of it, and then we are basically scaling it. We are dividing it by 5. This is the average of 5. So once we get the value that is greater than 5, so we will take that value and we will pass it through this. This is the average temperature, and after it there is some scaling of it, which will basically give us the actual temperature, where PT, where this is basically the R divided by 100 at 0, and this is R divided by 100 at 100 centigrade. So these scalings will be used in order to get the actual value of the temperature. So this becomes the actual value of the temperature. So here we are plotting it. So we have a similar, just a copy paste version of it, because we have 4 sensors with the same configuration, and one sensor is connected with a SSR. We are also logging that data into the Excel sheet. So for that we have a, we are storing it in the same directory as the VI is stored, where date, time, and all the sensors temperature is written into the Excel file. So a PID control is also implemented for one of the sensors. So this is the actual temperature. This is for the sensor 1. So here, if we turn on the SSR, so once the reference temperature is reached, it will give us the high value. It will set that particular channel as high, otherwise it will be low. So let's look at the working demo of this code. Okay, so here we are testing it. So here you can see that the same algorithm is implemented here. This was the initial phase where the only one sensor was tested before implementation. So here we have you can see that the 32-bit data is coming, and we are extracting only 24 bits. So we have implemented the PID algorithm. So we have a read VI, we have a you can also see that at AC value, and to be converted to a temperature value, and the actual value, which is 28 point something. So this is how this is working, and it gives us very precise temperature value, which is as per requirement. To 4 digits precision was required. So the values were very precise from this sensor. So this is the PWM out, and whenever the temperature is equal to the or greater than the reference, it will be false, otherwise it will be true. So it will be true, so it will make the heater turn on. Once the heater is turn on, it will increase the temperature, and once we will get up to the reference the set temperature, the heater should turn off. So this was the logic implemented in the PID control. Okay, thanks for watching.